Hello, I'm Patty Simpson with Simpson Math. Let's talk about hypothesis testing. So a hypothesis test is a technique for testing a claim about a population parameter using statistical principles. So if you think about when I asked you or when I told you I knew when your birthday was, and I knew with 95% certainty that your birthday was between 1970 and 2010. I was sure of that, 95% certain. But if I started going and asking my students, is that your birthday? And I started hearing over and over again, no, I was born before 1970. I might adjust my thinking. I might think to myself, my confidence interval, something about those birthdays is different than what I thought it was. So that's kind of the idea of a hypothesis test, is that we have some statistic or some parameter that we think is true about our population. And then some evidence starts coming up that makes us think that maybe that parameter is not true anymore. And we'd like to test to see if that statistic or that parameter has changed. So here's another example of that. So back to the ages. So maybe I think my college students have gotten older. I'm noticing their birthdays are before 1970. And we thought before that the average statistic or the average age of our students was 22. Just making up a number there. But let's say that we thought our students' average age was 22. And now I'm thinking, well, maybe our average age is older. Well, let's think about this 22 for a minute. If I go out and I choose a sample of students and I look at that sample of students and I find the average age of that sample of students, remember that that average age, that sample mean, is part of a sampling distribution of sample means. And that sampling distribution of sample means, as long as I took a big enough sample, random sample, should be part of a normal distribution. So here I have this normal distribution. That's not very pretty, but let's go with it. And, then we did our confidence intervals. I knew that I was 99.7% confident that that age of a student, if I went out and got another sample and another sample, that 99.7% of the time, my sample mean would fall somewhere in this range. Okay, but I now think that my students are older than 22. Something's changed. Maybe the workforce is not as open to older people, and so they're coming back to school to get a college degree or something. So I think that my population has changed. And so I think my age of my students is older. So I have an alternative hypothesis. An alternative hypothesis we write with a capital H and a lowercase a as a subscript. Our alternative hypothesis is just a mathematical statement about our parameter. And it's the hypothesis that we want to gather information or evidence in favor of. It's also called the research hypothesis. So my research hypothesis, my alternative hypothesis, is that the age, and this is what we mean by a mathematical statement, the age is greater than, I think they've gotten older, our age is greater than 22. So I've made an alternative hypothesis. I think the age is greater than 22. So my alternative hypothesis is the age is greater than 22. Then the null hypothesis, or we denote that with a capital H and a lower script 0 there, is the mathematical opposite of the alternative hypothesis. And it's always going to include the equality, always. So here, if the age, I thought it was the age is greater than 22, then the mathematical opposite of that would be less than 22. But it always includes the equality. So it's less than or equal to 22. And this is our null hypothesis. Now, what we're going to do is we're going to go out and gather evidence. And we're going to try to find enough evidence to convince us that maybe the age has gotten older than 22, Or we're going to look for evidence, and we're going to see maybe that evidence convinces us or shows us that the age is not greater than 22. So if when we go out and collect the sample now, and we find that sample mean, we know that 95% of the time my sample mean should fall within 2 standard deviations. Well, if I get some sample mean out of there that's greater than that, that's out here somewhere, now I'm going to think that's weird. It's kind of like getting a student whose birthday is before 1970. I go, that's a little bit weird. Well, if I get a sample mean that is way out here, I go, that would be really, really rare that would happen. In fact, if this is 95% of the time, that means on the ends it's 5% of the time, and only 2.5% of the time would I get something that far out there. So then I start to think, maybe our mean isn't 22. Maybe our mean is something different. But if when I'm gathering evidence, if I get a mean that is within that 95%, then I go, well, no, I guess I'm wrong. That our age really is within that 22. It is something that it makes sense for it to be there. Even if I get something out here, well, 95% of the time I'm going to get a mean within 2 standard deviations of the actual mean. So once we have found this alternative hypothesis and this null hypothesis, our next step is going to be to gather evidence to help us to see, is our hypothesis true or not? And the way we're going to gather evidence is we're going to see, do we get some value way out there where we go, that's weird that I'm getting that value way out there. So that's just the basics of a hypothesis test, is that we have some idea about our parameter that's different than what we think the actual parameter is. And then we're going to gather evidence to test that theory to see, is it maybe the same, or do we find some evidence that makes us think that our parameter has changed? Math Made Simple is Simpson Math. Thanks for watching.